Hello students, welcome to MEMONEET. I am Shubham. Today I am your physics SME today. So we will be solving the BPT 10 question paper, which is like the chapters that are mentioned in the BPT 10, that in physics mainly these are TPM, thermal properties of matter, and thermodynamics, and KTG. These three chapters are mentioned, okay, in this BPT 10. So yeah, so first of all, what we will be discussing in this the BPT 10, and we will be discussing each and every question in details, so that you can understand the topics behind it and the concepts behind it. Okay, it is already mentioned in our explanation. Okay, you can see this is a detailed type of explanation. So but we will try to do this so that you can understand each and every question properly. Okay, so moving on to the first question. The first question says that a container filled with hot water, a container filled with hot water, a container filled with hot water cools from 60 degree to 50 degree, okay, in 4 minutes. Time is given 4 minutes, and 40 degree 30 degree in 8 minutes, the approximate temperature of the surrounding. So this can be done by Newton's law of cooling. Okay, so it is there. This is the formula is given by d theta by dt equals to k theta, means theta w minus theta s. Theta w means the average temperature, and theta s is the surrounding temperature. Okay, so now so there are two cases. This is the first case, this one is the first case, and this one is the second case. In the first case the d theta will be, what will be the d theta? 60 degree minus 50 degree, that means it will be equal to 10 degree, right? In the second case, in the second one, same d theta is equals to 10 degree. 40 minus 30 means it will be 10, and time is here 8, here time is 4. Okay, so surrounding temperature theta s is given, theta is and the theta w is equal to theta 1 plus theta 2. Okay, theta 1 plus theta 2 means here it will be like 60 plus 50 minus by 2 means 55. Here it will be like 40 plus 30 by 30 equals to 35. So in this case theta w will be equals to 35, and in this case theta w will be equals to our 55 degree. Okay, so these two are the theta w, but in both the cases theta s will be, because surrounding is not changing, so surrounding temperature will remain constant, right? So what can we do? D theta by dt, okay, the approximate temperature d theta by dt, we have to case 1 and case 2. This is written in our explanation also. Okay, so this is the thing. Is written. Now if you divide these two equation, either you can write this unit or not, because in equations you cannot, but you sometimes you can skip the units also, you know, I think. Okay, so this is like this is 10 by 4. Okay, 10 by 4, 60 minus 50, I already told you this is 10 by 8. Okay, so in here you will find that you will get 8 by 4 means 2. Okay, and in the right side you will find what did I told you, the theta w is here 55 degree, here theta w is equals 35 degree. So it will become 55 minus theta s, or it is taken as t. Okay, so 55 minus t, here it will become 35 minus t. So 2 equals to 55 minus t by 35 minus t. So cross multiplication will become 2 into 35 minus t into 55 minus t. So if you just multiply it, what you will get? 70 minus 2t equals to 55 minus t. So from that you will get minus t equals to, sorry, plus t equals to 70 minus 55 equals to 15 degree. Okay, so therefore you can say the answer will be equals to 15 degree. So the answer will be equals to 2. Right? Question number 2. Two cylinders of the same diameter and length, one of iron, another of silver, because two materials are different, so therefore their thermal expansion will be different also. As contacting shown, if the thermal conductivity of silver is 11 times that of iron, the temperature of interface A, means the contact temperature, the contact phase, this phase you have to calculate. Okay, so how to calculate this? Right, understand this. Same concept, the change in the temperature per unit time del theta by del t equals to K into A, the surface area, into the change in the temperature divided by L. L means the, you can like this is the L length, or you can say the width of the section. Width of the section you can mention, right? And it is told, it is there the diameter and length is equal. So both the cases. So this is of no value. Okay, this is of no value. The K, A and L portion will be equal because diameter is nothing but it will give you the surface cross sectional area. So as the cross sectional area is equal, therefore A will be as the diameter is equal, therefore the cross sectional area will be equal to, and length will be equal to it as it is already given, right? So one of iron, another of, okay. So the main difference is the K, okay, the thermal conductivity, okay, and the change in the temperature. Change in the temperature is here. If you take this as theta, so it will become, here it will become 100 minus theta, and here it will become theta minus 0. So in both the cases the temperature difference is this. So now if you equate this, equate the equation del Q by del T, as these two are connected, so therefore change in the therefore the given heat or the heat transferred will be equal in both the cases. So del Q by del T will be equal in both the cases, like for the iron and for the silver it will be equal. So from that you can say like this, these two are the equations. First of all, first equation will be this, the K, this equation first, this one is the silver equation, this one is the our what to say, this is our equation of ferrous. So but in case of ferrous it will be like this is 100 minus theta, not theta minus 0, this is 100 minus theta only, right? This is 100 minus theta. Okay, now it is given that in the question it is given that in the question it is given that this Kag is the thermal conductivity of silver is 11 times. So that means K of silver is 11 times of that of iron. So put the values here in this equation. In place of Kag, put 11 into Kfe. So Kfe and Kfe will cut out. Okay, so it will become 11 theta. Okay, it will become 11 theta equals to 100 minus theta. So it is 100 minus, not theta minus 0. This is 100 minus theta. Okay, so from this you can say 11 minus theta plus theta will become 12 theta equals to 100. So theta will become 100 by 12 equals to 8.3. So answer will be 8.3. Question number 3. (200 joule of heat is required to raise the temperature of 2 moles of an ideal gas at constant pressure 15 to 25. The temperature differentiation is 10 degree del theta. The amount of heat required to raise the temperature of the gas from the same range at a constant volume. Okay, constant volume. Constant volume means the specific heat at constant volume is Cv and specific heat at constant pressure is Cp. So and the relation between these two are Cp minus Cv equals to R, as you already know this, and Cp by Cv equals to gamma. These two are the relations between Cp and Cv. At constant pressure, the Q is given by the formula Ncp dt equals to 200 joule, and the mole number N is given as 2 mole. Okay, and the del T is given as 10. So from that you can say Cp equals to 10 joule, and we already know Cp equals to Cv. Sorry, Cp minus Cv equals to, I already told you this. So that means Cv will become Cp minus R. Cp is given, Cp is already got 10, and Cv is and R value of R is 8.314 in SI, right? In SI, and in CGS it will become 8.314 10 to the power 7. So if you take this, you will get Cv equals to 1.686. Now put the value of Cv in the calculation of the heat transfer. That is equals to del Q equals to Ncv dt. dt will be equals to 10 because 10, 15, 25 to 15 means 10 degree del T, and Cv is equals to 1.686 and N is given as, so if you multiply all of this you will get 33.72, right? Simple concept is just remember the formula between the relation between Cp and Cv. Okay, two relations are there, already told you. Okay, question number 4. A flask contains argon and chlorine in the ratio of 2:1 by mass. Okay, the temperature of the mixture is 127, and if the atomic mass of argon is 40 unit, the molecular mass of chlorine is 70 unit, and the ratio of the root mean square. Root mean square VRMS is given by the formula root over 3 RT by M, where you already know what are these. R is the universal gas constant, T is the temperature, M is the molecular mass. Okay, in case of argon, the molecular mass is, this is 35.5, or yeah, oh no, it is already given. No, atomic mass of argon is given as 40 and chlorine is given as 70. Okay, so already given. This is generally it is 39 and this is 71 generally, but here it is, these two are given. Okay, so you can say that in this formula of VRMS, this is constant, and the temperature, they are, both the gases are in also same, so therefore these three are constant. So therefore you can say VRMS is proportional to 1 by root M. Okay, so that means you can say V argon by V chlorine will be equals to root over of M chlorine by M argon. Okay, because they are in inversely proportional relation. M chlorine is equals to 70, so 70 by 40 M argon, so 70 by 40 will become 1.75, root over 1.75. you already know this is almost equals to 1 this is equals to 1.75, sorry, 1 point root over 1.7, that is equals to root 3. Root 3's value is equals to 1.732. Okay, so if you calculate this root over 1.75, it is equals to 1.3, around 1.3, because 1.69 is equals to 1.3. The square of 1.3 is equals to 1.69, and 1.75 is nearly about that. So if you calculate this, the answer will be equals to 1, the near about 1.3. If you follow this, you will get the answer number 3, 1.32. Calculation should be done in approximation, so that it will not take much time. Otherwise it will take more time. If you just looking for like the perfect answer, it will take time. Okay, a cup of tea cools from 80 to this 0.1, del Q equals to 0.1 in 5 minutes. T is equals to 0.1 by 5 dq by dt. Sorry, this is d theta. This is d theta and this is dt. The temperature of the surrounding is theta s already given. Then how much time it will take to cool from this one to this one? Newton's law of cooling varied here. Okay, same already I told you, like d theta or dt by t, dt equals to k. This is theta s, this is theta w, already in the first question. This is theta s, the surroundings. Okay, put the values here. In the first case, this will become 0.1. No, d theta means 0.1 by the time is 5, and t plus t2 means 80 plus 79 by 2. Okay, and the t naught or the surrounding is 20 degree. Same in the second is 70 minus 0.16 by t. Here the t has been calculated, and this is k minus. So all the things are equal, more or less equal. This, if you divide this equation, this cancel out. Okay, this will cancel out. T5 will be there. Okay, T5 will be there, and you will get 80 plus 79.9 means around 80. 80 minus 20 means you will get 60 here. And here you get 130, you get 70 plus around 70, it is 70 plus 17, 140 divided by 2 means 750. Okay, so that means you get t by 5 equals to 60 by 50. So 0 0 cancel out, 5 5 cancel. So t1, it's simple. Don't do any kind of product, anything. Always do approximation. Approximate values should be taken to get the question 6. This is at 50K, heated Kelvin at constant pressure 1 atm. Okay, this is still a gas is the final one. The rate of heating is constant. Which one of the following graphs represent the variation of pressure with K? Liquid is in. So temperature is rising. The temperature is rising to 300 K. And the pressure is constant. Pressure is constant means this is following the formulas of Charles's law. Pressure is constant means Charles's Okay, the heating effect of points of the graph represents the variation of temperature with time. Okay, so in the Charles's law, if you see there is a variation of V and T, and these two are directly proportional to each other. Now in the explanation, what you can see, when the liquid oxygen is heated from, the temperature gradually increases. ठीक है ठीक है, तो मतलब कि क्या, the thing is that 50K to 300K it is increasing. At boiling point, the liquid and the gaseous states are in equilibrium. After this point, some of the heat applied does not affect the temperature of the liquid oxygen. After it reaches, if you have the concept of latent heat, whenever the state of the matter changes, after that, if you increase the heat or decrease it, doesn't affect the state of the gas or anything, any matter. Okay, so this is the in this case, this is the latent heat of vaporization. The liquid oxygen is converted into gaseous oxygen. Okay, so this is the thing. After some time, the temperature starts increasing and the liquid state is completely converted into gaseous state. At the point, if this is the graph, if you notice this point where the latent heat is provided, okay, in case of water, the water vapor, it was 540, okay, but this is the portion of the graph where we are providing heat that is converting the solid state to liquid state, and this is the liquid state of latent heat, and after that the liquid state is directly converted to the gaseous state. Okay, this is the graph. So in this case, what you will see, the liquid state is directly converting to the our this gaseous state. Okay, so therefore there is no, this portion is not there, so only this portion is there. That means the temperature is first of all rising, then at the point of latent heat of vaporization it is there constant, after that it is keep on increasing with respect to time. So therefore you can say graph number 3 is the correct one. Okay, question number 7. When the temperature of an ideal gas is increased, its molecular kinetic energy increases. There is a formula, right? If you see that the temperature is the kinetic energy of the molecules, and temperature is directly proportional to the velocity of the particles is directly proportional to the square root of the temperature. Okay, this is the formula. So in the question, this is the kinetic energy is directly proportional to the T, and this is, so if the options, it is that is molecular kinetic energy increases, potential energy decreases. Okay, it's molecular kinetic energy or potential energy decreases. No, it cannot happen according to the law of conservation of energy. Molecular potential energy decreases, maybe molecular kinetic energy increases. With the increase in the temperature, there is no mention of the potential energy, so therefore only the kinetic energy is with the increase in the temperature. You can say the kinetic energy. It is already I told you. Okay, so therefore you can say temperature, the increase of the the molecular kinetic energy increases. Right? Simple is there. Oxygen molecular 0 to 273 K. This is the formula there, no? Kinetic to kBt. Kb is the oxygen is the diatomic gas. Therefore it will become 5/2. This is 5/2. Okay, so yeah, and it's a diatomic molecule. Therefore the 5 is the degree of 3 is positional, 2 is rotational. Okay, freedom number, this degree of freedom number degree. So okay. So that means K, kinetic energy will be equals to 5/2 K, or let's say in case of K, R by Na, where Na is nothing but the our number, which is equals to 6.22 So 5/2 8.314 divided by this is the all of this. Okay, now do one thing, this calculation 10 to the power minus 23 will be there. Okay, so if you do this, 5/2 means 2.5 plus 20 divided by 20 into 20 divided by 6, it is around 3 into 2 centimeter will become 8 or 8.9. So near to that is equals to 9.42. Okay, 10 on this is plus 21, as we already got 10 to the power minus 23. So the answer will be in the power of the 10 will be equals to minus. Okay, so therefore you can say Okay, so therefore you can say option number 1 is the correct one. Just by applying approximation, just do approximation, nothing else. If you want to calculate the whole thing, it will take lots of time. Okay, the bodies of X and Y of identical geometrical mass and surface finish, but different materials are getting cooled in their atmosphere. Okay, variation of temperature T with time is shown. If Sx and Sy are the specific heat, then okay, T versus temperature versus time graph is there. We already did one thing. Okay, so this is the thing. Newton law of cooling, from Newton law of cooling you can say minus d theta by dt is proportional to 1 by S, where S is the specific heat. Okay, the inversely proportional to the specific heat. It is cleared from our Newton's law of cooling. So if you can say, if you see that the d theta by dt, or this is the d theta by dt is the nothing but the slope of these two graph, slope of this graph. This is d theta by dt of Sy, this is Sy, this is Sx. If you do this like by means of a specific, yeah. So that means if the slope of any graph is more, the specific heat will be lower. If any slope is greater, the specific heat will be lower, as they are in inversely proportional relation. And if the slope is lesser, the specific heat will be greater. Okay, simple. In this given graph, you can say the slope of Sx is greater than that of slope of Y. So therefore you can say slope of Y, specific heat of Y will be greater than that of specific heat of X. Yes, here I already told you the same thing. Slope of X is greater than that of slope of Y. So therefore you can say specific heat of Y is greater than that of specific heat of X. Simple analysis of graph, we will do this. Question number 10. If two balls of same metal weighing 5 gram and 10 grams strike the target with the same velocity, the heat energy so developed is used for raising the temperature alone, then the temperature will be, first of all, see this thing, yeah, same thing, yeah. Heat is produced during when we throw something, and if it is striking with any surface, is given by the mc del T, where C is the specific heat, and this specific heat is generated during the as we are throwing the ball. That means the kinetic energy converting into heat transferred to the body, and so therefore the kinetic energy will be equal to this heat produced. Okay, so if we equate this to equation, we will cancel out. So V will be to 2c del T. That means V is proportional to V square is proportional to D. That means the increasing is the mass of the particle or the object. So therefore we can say it doesn't matter how much two balls weigh, it will be the weight of the particle. So therefore these two are of similarity, because the no temperature is a loss, so it will be above, right? Shown in the figure the ratio d1 by d2 by 3, it is k1 time on phase. Similar that in this numerical simplify chart the V quantities. Okay, therefore if I relation between the full formulas. So in this thermal conduction, in this formula we will do the thing is that the common is given by the formula is K equals to what? K equals to this. So this is in K into D1 into T1, K into K2 into D will be T2, where K2 plus K1 D2. We put all the values. So from this you can D by D equals to 3, so D1 square 2 by D2. So D2 instead of D1 you can put 2 by D2. Same here. Okay. After we calculate, we will get in the portion top we will get plus 60 by 2. So that 100 will come. One you take out. Right. One portion you take out. Right. Okay. Question number 12. It's like water is given by AB and AC. AB and AC. This is the OA for solid heating. Solid to, and this is the sublimation process. No, OA to AC. Sublimation process. Camphor. In case of air, we can that. In case of solid is converting into right. Therefore, you can say the OA curve is nothing but the sublimation curve. This is the sublimation curve. And this is the curve of fusion. AB is the curve of fusion. That means solid is converting into liquid, or the other way around maybe also occurs. Okay, but in this case the direction, if you see the direction, solid is converting into liquid. case of fusion. And AC in the portion of AC, you can say AV and AC, these two are coexisting. That means liquid is converting into vapor. This is called the vaporization. So therefore you can say OA is our sublimation, AB is our fusion, and vapor, this AC portion is our vaporization. So therefore you can say option number 2 is the correct option here. So just go to the direction, go like the direction, you will get the answer. Question number 13. No, VRMS, VAB, VMP. What is this? RMS velocity, average velocity, and this is the mean velocity, most probable velocity. Okay. So Maxwell velocity distribution. So you know this formulas, no? RMS is equal to root over 3 RT by M. This is already given, VRMS, and V average is given by this formula, root over 8 by RT by M, and VMP is given by root over 2 RT by M. Okay, same thing. Now take the ratios of these three. What you will get? 1.732, 1.595 and 1.414. This is the value of root 3. This is the value of 1.414. This is the value of our 8 root over 8 by pi. So if you put all of this, like what you will get, the RMS is 1.732. No, IRMS is 1.732. So therefore it is the highest value. V average is the second one, and the V most probable speed is the last one. So therefore if you just arrange them in a decreasing order, so the VRMS is greater than VAB, greater than VMP, right? Remember those formulas, then and then you will get it, otherwise you will not. Monoatomic gas, pressure is P, having a volume of V, expands isothermal process to a volume of V. Volume is thrice. Okay, adiabatically to the volume of V, then adiabatically for, there are two steps. Okay, first one is the isothermal process, second one is the adiabatic process. The P1 V1 E2. So P2 here will be P. No, the increment, so the pressure is by 3, so it's 3 slow. The adiabatic equation is given by the formula P V to the power gamma is equals to constant, right? P V to the power gamma is equals to constant. P V to the power gamma is equals to constant, right? P V to the power gamma. Process. Put the value same value. P1 is a P, so P2 you will put P by 3 to the power gamma. P3 here is already given. Sorry, you have to calculate final pressure. P3 you have to calculate V given V. So if you do all this, if you calculate all of this, what you will get? 3 to the power gamma by 3 means 3 to the power gamma minus 1. P cancels. P3 will become 3 gamma to the power minus 1. V to the power gamma will cancel. So that means P3 will become 3 gamma to the power minus 1 into P. Okay, and value for monatomic already given, the monatomic is the value of it will be 3 to the power 2 by 3 into P. So answer will be option number 6. Remember, the equation is P1 equals to P2 V2, or PV equals to constant, and in case of this adiabatic process, PV to the power gamma is constant. Okay. Question number 15. Which of the following is the triple of the water is absolutely wrong? Okay, burns from steam are more severe than that because it contains the extra lattice, which is responsible for the more inside the steam, like the water that has steam temperature. Okay, that is equal for temperature. You already know that is the evaporation. Is less than temperature. When a fully inflated balloon is immersed, the polar it will contract because of tension. It will contract. Okay, it will contract, right? So therefore you can say option number B and option C options. Ethyl alcohol, the alpha is the expansion mercury, so therefore forms already tail of mercury is better than that of alcohol. So that means it will find more, and it has the mineral property also. Okay, Carnot engine. Carnot engine is like deduct from the assumptions we already providing, because sometimes what happens, like you can see that internal resistance that is there, the decay is not there, but still providing the question. Therefore we just added 1 to here, so you can get the, you don't forget the knowledge about this. Okay. LT in this is 5 minus 8 become 200K. This is available means this is work done for kind. Okay, so the efficient Carnot engine is given 1 by 2 by 3 to this T2 300 by 500. So this is become 2 by 5, 40% efficiency. Okay, so and we already know the efficiency is given by output by input. Output is the work done, Q is the input is the heat provided. Substituting the values, what you will get in case of W, what you will put in case of W, what you will put, and this is there 1 kilojoule means 1000 joule, 1000 by and the eta is here 2 by 5, that will the Q will become 2500 joule. Okay, and we already know that W is equals to the work done is equals to the change in the according to the first law of thermodynamics, dq equals to du plus dw. That means if the internal energy is like the constant, so therefore dq will become dw. Okay, so that means dw will become dq means q1 minus q2, right? So therefore you can say q2 is equals to this q2 will be equals to our w minus q1. Okay. Okay. No. Okay. Okay. Right. So it will become q1 minus w. No. q1 minus w. Sorry. Yeah. q1 minus w. Right. It will become q1 minus w, not w minus q1. q1 minus w. Right. So this q1 is equals to 2500 already calculated, and the work done is already there. That is 1 kilojoule means 1000. So therefore find the heat transferred to the engine by the reservoir, that will be equals to 2000 minus 1000 means 1500 only. Okay, so therefore the temperature, final temperature is 1500. Okay, question number 17. A faulty thermometer reads 5 degrees Celsius as a melting point of ice, 90 degree as a steam point. This is what 0 degree Celsius. This is generally 100 degrees Celsius. The correct temperature of F when its faulty temperature thermometer is at 52 degrees Celsius. There is a formula that is given by C by 5 equals to F minus 32 by 9. Okay, this 32 is nothing but the lower limit of thermometer. Okay, so the T degree, the temperature scale is linear, so we can say that T degree Celsius minus the T degree means the temperature we are calculating by minus ice point divided by steam point minus ice point. Okay, equals to F minus 32 by 180. Right. So if you calculate, put all the values, T degree is here is 52, that already given, and 52 minus 5, 99 minus 5. Okay, 99 minus 5. Okay, F minus 32. F is the reading in the Fahrenheit scale. So after calculating this is 44, 47, 94. That means it will become 1 by 2. Right. 1 by 2 equals to 5 minus 32 by 180. So F minus 32 will become 90 only. 180 will cut out. Hello students, welcome to the next part of this BPT 10. So we will be solving from question number 18. Okay, I already told you the descriptions of this BPT, which chapters are there. So we will be solving this from question number 18. From in the part 1 we solved 1 to 17. In the second part we will be solving from 18 to the rest of the questions, if we can do this. Okay. So the question 18 says that plot the graph between the temperature in degree Celsius along the x-axis and degree Fahrenheit and y-axis. So if the graph is a straight line, then it is the straight line graph is given by the y equals to this y equals to mx plus c. No, m is the slope, c is the intercept. So the relation between degree Celsius and degree Fahrenheit scale is c by 5 equals to f minus 32 by 9. Here c by 5 equals to f minus 32 by 9. So after calculating this, we will get f equals to 9 by 5 c plus 32. So here this is our m and this is our c. Okay. So if we take this, if you see this, that the intercept is a positive one and the slope is also a positive one. Okay, so if we follow through, if we plot the graph, this graph will look like this only, and this is the 32 portion, this is the intercept, 32 y intercept. So you can say this, so from this we can say this the option number 2, where this is written that intercept the y is positive, so therefore you can say option number 2 is the correct one. Okay, question number 19. The temperature of gas is minus 50 degrees Celsius, that means it is equals to 223 Kelvin. To what temperature should the gas be heated so that the RMS speed is increased by 3 times? Okay, the first RMS speed was V1 is V. Okay, V1 is equals to V, and V2 will be equals to V plus 3 times the V. That means equals to, it will become 4 times V. And here you know the relation between VRMS is given by root over 3 RT by M. So here in this case the V is only depending on the temperature. As I already told you in previous questions, you need to write only only the quantities which are related, which are changing, which are the variables. Constant quantities you don't need to write. Okay, so therefore you can say V is proportional to 1 by root over m. Okay, so that means you can say, from this, like you can say, sorry, V1 by V2 equals to root over of m2 by m1. Sorry, so not m, here it is not dependent on the m, it is dependent on the temperature only. No, temperature. So the relation between temperature is here you have to write this. You have to write this T, root T. Okay, so the V1 by V2 will be equals to our T1 by T2. T1 is 223 and T2 you have to calculate. V1 by V2 will be equals to V by 4V, means 1 by 4 equals to root over 223 T2. So T2 will become 4 square, means 16 into 223. So how to calculate this? 16 into 200 means 3200. 16 into 20 means 320, that means 3520 plus 48. 16 into 3 means 40, so that it will become 3568. This is the simple way to calculate, to multiplication, do the multiplication. So 3568 is Kelvin, so minus 273, it will become 3295. So therefore answer of 3295 will be the answer. Question number 20. The mean free path of the gas with molecular diameter d and the number density n can be expressed as. So the mean free path. What is the mean free path? First of all, the mean free path of the gas is defined as the average distance of an object that will move between collision, and it is directly proportional to the pressure and the diameter of the molecule. Okay, and the formula is given by lambda is equals to kt by 2 root over 2 pi nd square. Okay, kt by root over 1 by 2 pi nd square. Where d is the lambda is the mean free path, n is the mole number, and k is our constant, and t is our temperature in Kelvin. Okay, so these all are the things. Molecular d is the molecular diameter, and n is the number density. This is the thing is written here. So from this you can say lambda is proportional to, if this is the constant portion, so if this is the constant, the lambda is proportional to 1 by root over 2 pi nd square. Okay, this is a very simple concept is there. So the thing is that from the question you can say this is written in the option number 1. So lambda is proportional to 1 by 2 pi nd square. So therefore option number 1 will be the correct option. Question number 21. 4 identical rods are arranged as shown in figure. The temperature of the junction. Okay. In this question there is one thing missing. This will be 10 degrees Celsius, not 0 degrees Celsius. This is 10 degrees Celsius. Okay, 10 degrees. So 10, 0, 10, 30, 40. Okay, so calculating the junction temperature, what you have to do, this is the just by as these are all are connected, so therefore the temperature dq by dt, not d theta, this is dq by dt. The temperature, so the heat produced or the heat generated or the heat supplied will be equal dq by dt. Okay, dq by dt is given by the formula del theta equals divided by 1 by ka. Okay, so in this Ka portion in all the cases will be equal, so that means we can say del theta in all the cases, if we sum this up, it will be equals to 0. Okay, right? So therefore you can say theta minus 10 for the first, this one. Second one is theta minus 30, theta minus 40, theta minus 0. So that means it will become 4 theta minus 30, 40, 10, it will become 80. Okay, equals to 0. So that means theta will become equals to 20 degree. Simple concept. If the rods are connected, therefore the temperature or the heat supplied will be equal. Right? Question number 22. A body at temperature T is getting cooled at atmosphere of temperature T naught. Okay, assuming the Newton's law of cooling is valid, which of the following is the variation between ln T minus T naught and time T? Okay. First of all, understand the Newton's law of cooling is that Newton's law of cooling states that d theta by dt equals to our k into theta s theta w minus theta s, where theta w means T1 plus T naught or T minus T naught by 2, and theta s is the surrounding temperature. So this is the this is the modification form, dt by T naught minus k dt. Minus sign is there because this is the law of cooling, where the temperature is going down. Okay, so minus negative symbol is there. So if we compare this with equals to y equals to mx plus c equation, first of all integrate the equation. 1 by x integration will become ln x or log x. So here x is the t minus t naught, so it will become ln t minus t0, and this will become k into t plus c. C is the integrational constant. So c is the intercept here, minus k is the slope here, and this is our y. So if we compare this with y equals to mx plus c, so m will become negative minus k, so the slope is negative, and c is the intercept. So if we take the graph, so therefore in the graph number 4, you can say this, the negative slope is there. Question number 23. If the RMS speed of H2 at NTP is 1.84 km and the RMS speed of O2. Okay. So first of all, go through this question. You can see VRMS. VRMS here only will depend on the molecular mass m, because no temperature is mentioned. And in the formula VRMS is 3RT by m, where R is the constant and 3 is a constant number also. T is not mentioned, therefore V will depend on the m only. Okay. So V by VH by VO will become MO by MH. MO means 32 by 2 means into root over 60 means 4, and this is VH is 1.84. So therefore V naught will be equals to 1.84 by 4, it equals to 0.46. So therefore option number 4 is the correct option here. Okay, same thing I am repeating every time, that the velocity or the any two and any three factors are there mentioned in the question. You have to calculate through this only. You don't need to write the whole formula there. Question number 24. PV graph is plotted, semicircular process of ABC. Okay, and the options are given. Some 4 statements are given. You have to take which option is the correct option or the correct explanation of this. Okay, P versus V graph is there. So this is the graph that is going down. Okay, the direction is the going down option. So this is the walk down, PV walk done is there. Okay, this portion, ABC portion, cyclic process. Okay, in the cyclic process, dU is equals to 0. You already know internal energy will become 0. dQ will be equals to dW. Okay, from the first law of thermodynamics, right? So in this portion you can see this is not an isothermal process. Okay, this is not an isothermal because the temperature is changing, bro. But what you can see that in this process ABC, as that this is going down. Okay, this is downgrade. This is going in the downward direction. So you can see the heat is releasing. Some amount of heat is releasing. Okay, some amount of heat is releasing in the case of ABC. So therefore you can say option number 2 is the correct option, because W is less than 0, U is less than 0, so this process ABC, so you can say Q is less than 0, so that means you can say heat is released from the first law of thermodynamics. You can say work done is in ABC is 0, never. Work done will never be 0. It is less than 0, but it will not be 0. It will be negative but not be 0. In the BC work done the gas is negative. Now BC work done the gas is positive. Okay, the BC work done is positive, right? Question number 25. The black body is at high temperature of T Kelvin, emitted the thermal radiation at a rate of some T. Okay, so first of all, let me clarify something. Most of you guys will think that the black body radiation is omitted from the syllabus. Why the question is there? The thing is that in this year's NEET question, you can see that there are multiple topics that are omitted, but some questions are there also. So you are providing some deleted topic questions so that you can be prepared if this kind of things happen in the future or in the 2025 NEET. Okay, so 1 to 2 question you will find there is one question from Carnot engine, there is this question from radiation, which is not in the syllabus, but we are providing 1 to 2 questions are there, that is mentioned. Okay, yeah. So the thing is that this is proven by the this Stephen's law. Stephen's law states that E the radiation is equals to A into sigma T to the power 4 E into sigma into A T to the power 4, E into A sigma A T to the power 4, but E is the emissivity, sigma is the our this, and sorry, Stephen Boltzmann constant, A is the surface area, and T is the temperature, and E is the emissive power. So you can say the radiation rate of the emissive power. This is in this question, this E is only depending on two things: the emissivity E, and the temperature. Other than that, nothing is you need to consider, because I already told you you have to consider all the variables only. The constant part is not needed. Okay, so E1 by E2 here will be equals to, and remember one thing, for a black body, small e, emissivity is equals to 1, because it it absorbs all the ray that is coming its way. Okay, E1 by E2 it will be equals to T to the power 4, because emissivity is 1 in case of this black body, and E2 will be equals to, E means here 0.725, and T to the power 4 means T by 4 whole to the power 4. So it will become T by 256, T to the power 4 by 2, T to the power 4 cancel out, 1 by 5, 0.5 means 1 by 2, so 1 by 2 into 256 means 512. Okay, it will become 512. So therefore E2 will become nothing but E2 will become E by 512, E by 512. So this is the main thing. Okay, question number 26. A Carnot engine whose sink at 300 Kelvin has an efficiency of 40%. Eta is given. By how much should be the temperature of the resource to increase as to the increase in efficiencies by 50% of the original efficiency? Question number 26. Okay, T1 is 500 Kelvin, is there 300 Kelvin. Okay, okay, efficiency is eta T2 T1 minus T2 by T1. So efficiency is 0.4. That means T1 minus 300. So the T1 will become 500. So you can calculate this. No, the 1 minus 300 by T 0. So it will become 0.1 minus 0.4 equals to our 300 by T1. So T1 will become 300 by 0.6 means equals to 500 Kelvin. This is already mentioned, 500 Kelvin. Okay, so in the second case the efficiencies become 50%. No, 50%, right? So 50% it will become the previous one. So that means the 50% of previous one will be increasing. It is increased by 50% of the previous one. That means 0.40 was the previous one. Now the 50% of the previous one increase means 20% increase. So 40% plus 20% it will become 60%. The efficiency will become 60%. So from that you can calculate this. So same thing, same process. It will become 750. The increase in the temperature, previous one was 500, now 750. The increase in the temperature is 250 Kelvin. Okay. Question number 27. A geyser heats water flowing at a rate of 8 liter per minute. Okay. 27 to 55. The d theta is 50 degree. If the geyser operates on a gas burner and it heats, combustion is this at this joule per gram, then what is the rate of combustion of fuel? Okay. This is a very good question. Okay, so the first of all is the mass of water heated. Three liter. Okay, the mass of water heated is 3 liter. 3 liter means you have to calculate in like a gram or in this. So you have to multiply this with density. Mass of water. So the density of water is 3 liter is the our V, volume. M equals to dV, mass equals to density into volume. Density is 1000 in SI, in series it is 1. So if you multiply this, you will get the 3000 gram per minute. In per minute is mentioned. Okay, the temperature, the heat is this, and you know this H equals to MST or Q equals to MC del T, which is the change in the temperature. So M is already we got it, and C is hour is 1 in case of this, and this is 50. So if you calculate all of this, what you will get? 6.3 10 to the power 5 joule per minute. So first previously it was in calorie, but now if you if you convert this into the C into like SI, you will get 4.2 joule per minute. So the thing is that the Q value will be equals to 6.3 10 to the power 5 joule per minute. So after that the combustion rate is given, so you have to calculate what is the rate of combustion, sorry, the heat of combustion is given. So if like what to do, you have to calculate this is given, this is already we got joule per minute, the amount of this amount of heat, and this is the joule per gram, the rate of fuel, the heat of combustion. So if you divide all of this, what you will get? You will get the rate of combustion. Rate of combustion is the gram per minute, or the per minute the amount of combustion is done in of water. Okay, so it will if you divide this, you will get around 15.75, which is nothing but almost equals to 16 gram per minute, right? Okay. Question number 28. Liquid A and B are 40 degrees 30 degrees Celsius. When mixed in equal masses, the temperature of the mixture is found 30 degrees Celsius. The specific heat is in the ratio. A and B are mixed together to get the equal masses. The temperature of the mixture is 36 degrees Celsius. Okay. Okay. So the thing is that, yeah, same formula we will calculate. In the first case, the change in the temperature is 4 degrees Celsius. In the second case, the change in the temperature is 10 degrees Celsius. The same formula we will get in both the cases. The heat is equal. Okay, because they are mixed together. So that means one will be losing heat, another will be providing heat. So these will lose heat as the temperature is highest compared to this one, and this one will gain heat. Okay, so heat gained equals to heat lost, that is calorimetric principle. Okay, so heat gained here is equals to heat lost here. Heat is given by the formula mc del T. So del T here is 4, del T here is 10. Okay, so the same thing is equal masses means mm will cancel out, C you have to calculate. Okay, so del T by T it will become, sorry, this is not 10, this is 6. No, so that means C is proportional to 1 by del T. So therefore C1 by C2 equals to T2 by T1. T2 here is 6 by 4, it will become 3:2. So therefore option number 1 is the correct option here. Simple. Question number 29. A mixture of gas contains 2 moles of O2, 4 moles of argon at temperature T. Neglecting all the vibration models, the total energy of the system. Total energy is given by the formula F by 2 energy, where F is nothing but the degree of freedom, N is mole number, R is the universal gas constant, and T is the temperature. So the total energy will be equals to energy of oxygen plus energy of argon. Okay, so now put all the values of F. This argon is a inert gas, so it is a monoatomic gas, and this oxygen is a diatomic gas. For diatomic gas it is 5 by 2, value of degree of freedom 5 by 2, and for monoatomic gas it is 3 by 2. So put the value. Okay, so put the value here. So what you will get, you will get that U is equals to 11 RT. 2 cancel out, 4 2 cancel out, so it will become 2 into 3 means 6, 6 plus 5 4 11. 11 RT will be the answer. So therefore option number 4 is the correct option. We heat a gas sample from 27 to 320, that means 300 degrees Celsius is the change in the temperature. When the individual kinetic energy of the molecules is UE, what will be the average kinetic energy? Okay, there is a formula, the kinetic energy E equals to 3 by 2 kBT. No, kB is the Boltzmann's constant. No, so you have to calculate the energy change in the energy. So therefore you can say E is proportional to T. E is proportional to T. Okay, so first so that means E1 by E2 equals to T1 by T2. T1 was 300. This one is 600. Okay, so this is 2. So E2 will be equals to 2 into E1. So therefore you can say option number 1 is the correct option. Simple formula is there. Simply apply the formula, you will get the answer. 31. 3 identical metal rods Ka, Kb and hello students, so we will be moving forward with the last few questions of this BPT. Okay, so the first question here is, the previous one we covered from 18 to 30, so in this we will cover from 31 to 50. Okay, so the 31 to 50 question number 50 states that, question number 31, three identical rods in dimension A, B and C are placed end to end at a temperature difference is maintained between the ends A and C. Okay, T1 equals T1 and T2. The thermal conductivity of B is thrice that of, okay, so B is thrice that of C. That means KB equals to 3 of K, C is 3K, and the half of that of K, that means KB equals to KA of by 2, that means KA equals to 2KB, right? 2KB means 3K, that means it will become 6K. So if we just simplify the diagram, it will become like this: 6K, 3K, sorry, it will become 6K, 3K and K. Now you have to calculate the equivalent K. So if equivalent K is R by 6, sorry, equivalent is this thermal conductivity, this you can calculate this 6K, 3K and K from equivalent will become NR by 9R by 6. Okay, so this is the resistance, thermal resistance. Thermal resistance formula is this 3LA by K, this, and here there will be a 1 by K also. Okay, in this portion 1 by K will be there also. So this is not, this will not be there. This is 9R by 6 into 1 by Ka, and if we calculate all of this, this A and A will cancel out, this L and L will cancel out, 3 and 9 will cancel out, it will become 3 by 6 means 1 by 2, 1 by 2K, that means K, 1 by K equivalent equals to 1 by 2K, that means K equivalent equals to 2K. Okay, this is the thing. Very simple calculation. Just go through the question wisely and thoroughly just write the complete equations, this kind of equations, then and then you get the idea. Question number 32. An ideal gas is compressed isothermally. Isothermal process means PV equals to constant. We discussed this in our previous questions also. Then allowed to expand adiabatically to regain its original volume. Okay, adiabatically means PV to the power gamma equals to constant. The ratio of the final initial pressure is, okay. So the thing is that the pressure here, the pressure is doubled. First case, pressure is doubled means volume will be halved, because PV constant means P and B are in inversely proportional relationship. Okay, inversely proportional relationship, that means the V will become, this will become V by 2. Okay, this is the there, and the adiabatic process I will told you PV to the power gamma equals to constant. Okay, so P1 by P2 here will be V2 by V1 whole to the power gamma, right? Because P and V are inversely proportional and gamma is the power. So here you will get the P1 dash, that is the final, or the P3, the third pressure. Okay, the P3 by P2 equals to 2 to the power minus 1 by 4. 2 to the power minus 1 by 4, 1 minus 1.4 is already given the value 0.38, right? So from that you will get this P1 dash or the P3 equals to by P2 equals to 0.38, and P2 is already we calculated, that already it is given that this is the twice that of initial temperature. So this will become 0.76 of P1, right? Now you have to calculate the P3 is to P1. P3 is 0.76 of P1, this is only P1, so therefore the option will be 0.76 is to 1. So therefore the option number 1 will be the correct option here. (38) 33. Cyclic process. Easy to remember. The formula is given as pi into A into B. Okay, in the cyclic process du will be 0. Okay, and the dq will be equals to dw. Work done is dw. Here it is like I mentioned here already, you have to calculate the work done. So this is our A, this is our B. Okay, this is our 2B portion, and this is our A by 2, this is A by 2, and this is our 2B by 2. This you have to calculate for calculating the area, pressure, volume, the work done. So how to work done will be equals to 2 minus 4, means 4 minus 2 by 2, it will become 1, and this A by 2 will become 200 minus 150 by 2 means 25, into pi. So therefore the answer will become 25 pi. The answer will become 25 pi. Here the answer will be positive because the area under the curve is a positive work done. So therefore option number 4 is the option. In the following process, heat is neither absorbed nor released by the system. So if you know this, that adiabatic process, no heat is absorbed or or released. Okay, the del Q is always equals to 0. The net exchange of heat with the surrounding is always 0. During the adiabatic state, no heat is absorbed from the surroundings and no heat is released. So therefore, according to this question 34, the answer will be the adiabatic process, not other. Isothermal, the temperature remains constant. Okay. Question number 35. If 20 gram of water at 30 degrees Celsius is mixed with one of the following samples of water, the final temperature will be maximum when the sample is okay. This is a heat and trial process. But how to do this heat and trial process is a very lengthy process, you know. So how to do this in a nominal time? So pick up the option where the temperature differentiation is greater. So in this case you will get that the 30 degrees Celsius temperature is there initial. So 40, 25, 50 and 80. So the maximum difference is here. So in this case you will get the maximum temperature differentiation. Okay, the maximum value of the sample. The final temperature will be maximum here. So calculate this. You can prove this. You can do this. Like in other cases, I will show this, and I will here it is calculated that theta equals to 38.3 degree. Like how to calculate the calorimetric principle. This is the here the heat will be lost. Here the heat will be gained. Okay, the heat lost equals to heat gain. So Q equals to mc del T. Here this formula is applied. The theta we got 38.3. Okay, this is 6 theta equals to 38.3, right? So now this is the thing. 38.3 is given. 38.3 we got theta equals to in this case, but in other cases we can see, like in this case question option number 2, if you see option number 2, if you see option number 2, this 40 this will lose heat and this will gain heat. Okay, so 20 into 1, don't need to write 20 into 1, so 30 minus theta, and here 40 theta minus 30, no, 20 40 it will become 2, so that is 30 minus theta equals to 2 theta minus 25, it will be 25, no, 50. So here it will become theta equals to will become 20 degrees. So 20 degrees lesser than that of 38.3. So therefore you can say option number 4 will be the correct one. And I told you how to choose the option. The temperature differences should be greater or more compared to the other options. Question number 36. 1 gram of water, volume 1 centimeter cube at 100 degrees Celsius is converted into steam at the same temperature under the normal atmospheric pressure, that is 1 into 10 to the power 5 Pascal. Okay, the volume of the steam formed equals to how much? 1671 centimeter cube. The specific heat of the preparation of water is 2256 joule per gram. The change in the internal energy. This should be calculated by our the change in the EU, the law of thermodynamics, first law of thermodynamics. Okay, so the thing is that question number 37. The coefficient of thermal conductivity of copper is 9 times that of steel. Coefficient of thermal conductivity, that means K of Cu, that is equals to 9 times of K of steel. In the composite cylinder bar shown in figure, what will be the temperature of the junction of the copper and steel? Okay, so this is copper, this is steel. So junction temperature is theta. So here it will become 100 minus theta. Here it will become theta minus 0. Okay, so the length is 8. This is 6. 3 times. Okay, we got this from the figure. Okay, the temperature of the junction is theta. Like the thing is that as they are acting as a system, therefore the total heat taken or the total heat release, total this thing will be equal. Okay, the heat transfer will be equal. So heat transfer is given by the formula K into A, the theta 1 minus theta 2 divided by our length. Okay, so this is this is there, and k1 equals to 9, k2 already told you here. Okay, so if you put the values, what you will get? 6, 18, it will become 3. K1 in place of 9, k2, k2 and k2 will cancel out, right? K2 and k2 will cancel out. So 9 into 100 minus theta means 90 minus theta, 3 into theta here. This is cross multiplication, 900 minus 9 theta. So that means 12 theta equals to 900. That means theta will be equals to 75 degrees Celsius. So therefore option number 1 will be the correct option again. Simple formula, Q by T in a like the system, the total temperature, the total heat like transferred will be equal, because they are in a connected with each other. Okay, and it is given by the formula K into A del theta by d theta or del theta and divided by L. Okay, put the formula there and you will get the answer. K into A theta 1 minus theta 2 divided by L. This is the formula to calculate this dq by dt. Okay, in heat conduction per the rate of heat conduction. Question number 38. A source of heat applies heat at a constant rate of solid Q. The reciprocal of the slope of the portion CD of the graph gives. Okay, reciprocal of the slope of portion CD graph. Reciprocal of CD graph. Okay, question number 38. We have to explain this. So this is a temperature versus heat supplied graph. No, so this graph shows us this. This is our what portion? This is our solid portion. This is our latent heat portion. This is our water portion, liquid portion. So this is our latent heat of vaporization. This is our vapor, water vapor. This 4 portion you already know. AB is the solid. This is a latent heat of fusion. This is liquid. This is latent heat of vaporization. This is latent heat of this is the gaseous portion. Okay, so what in that what we are getting D to C. Okay, in the D2C portion, so a definition of heat capacity is given by the formula dq equals to C. So dt equals to 40 by tq. Okay, graph. The slope of the TQ graph in the CD represents the inverse of the heat capacity of the liquid. CD portion. This is nothing but the inverse of the heat capacity, thermal capacity of the liquid. Why? I already put it. C it is converting from liquid to vapor, but in the D2C portion it convert to thermal capacity of liquid. Okay, this is the thermal capacity of liquid or latent portion of liquid. In here the heat is increasing with temperature is increasing with the of heat. So the liquid is converting to the gas here. In at that point, this point that is totally converted to the, if the latent is provided from the liquids. Okay, so they are all our latent liquid only. Question number 13. A certain is used to constant if heat Q is equal to the value of X is. Okay, is that this is the first law of thermodynamics, says that the del Q is plus dW. Okay, so the internal energy, that means du equals to Q by 4. Therefore, if you put this in the equation, W will be become 3Q by 4. Okay, it will become 3Q by 4, right? So, and we already know this, that U equals to Q by 4, so it will become 3 by 2 R del T. Okay, so and you can say this W is equals to W is equals to 3Q by 4, that means it equals to 3 into U, that means it will become 3Q by 4 means 9 by 2 R. Okay, and the other portion will become R by 1 minus X. So therefore you can say 1 minus x equals to 2 by 9. So therefore you can say x equals to 7 by 9. Right? All the things were already given in the question 39. When you make ice cube the entropy of water, what is entropy? First of all, understand. Entropy is related to the randomness of the particles of the system. More the randomness, more the entropy. We know that when the solid particles, okay, in the solid particles are converted from the liquid particles, then the entropy, we can say the entropy of the solid is less than that of liquid, because in the solid, what you can say, the molecules are intact with each other. Okay, the intermolecular distance is less, so therefore there will be less randomness, so there will be less entropy. So when we convert liquid to the ice cube, the entropy always decreases. Okay, always. Gas to liquid decreases, liquid to solid decreases, solid to liquid increases, liquid to gas increases. Okay, as the randomness increases. Randomness is nothing but directly proportional to the intermolecular distance. Question number 41. A body cools from temperature 40 to 3T in 10 minutes. Newton's law of cooling. The room temperature is T. Okay, question number 41 states that body cools from temperature 40 to 3T in 10 minutes. The room temperature is T. Okay, the Newton's law of cooling is applicable the temperature of the body at the end of 10 minutes. So there are two cases. First case 40 to 3T, that means the del T is equals to T, and in the second case that the 3T and the last temperature will be equals to T dash. Okay, take this. Okay, now do one thing, like that form two equation. In this first equation you will get that T by 10 equals to K into 5T by T, but just putting in this formula, that is equals to T1 minus T2 by T, K into, this is our theta W or TW, this is our T surrounding, TS. Okay, so put the values in the formula, you will get the answer here. And after this, in the second case, 3T by T dash, because the last temperature was 3T and the new temperature is T dash, by the next 10 minutes bits the time will be equals to 10. Put the value in the formula here, so you will get that 3T minus T dash equal by 10 equals to K into T dash plus T by 2. Now what, do one thing, T by 10 value put here, T by 10 value, it will become 3 into T by 10, so 3 into T by 10 will become 3 into K into 5 into T by 2. Okay, so here you will get a equation where you have already replaced this, and this will become T10 by dash, T10 by 10, T dash by 10. Okay, so now only T dash is remaining, and the answer will be in terms of T. Okay, so if you calculate, if you just replace the value of T by 10 here from this equation, then you will get that T dash equals to 7 by 3T. This is a very simple, like the replacement method. Just you can or you can do another, like you can also solve by other methods also. You can comparison method also. You can calculate the value of T by 10 from this equation, this number 2 equation, and then you can compare the values of these two equations. Okay, same answer will be there. 42. A 2-gram bullet is moving with a velocity of 200 meter per second, which is brought to sudden stoppage by an obstacle. Total heat produced goes to the bullet. Specific heat of the bullet is 0.02. The rise of the temperature will be, okay, nice. So the velocity, so the thing is that the object is moving towards a certain object, therefore the kinetic energy of the object is there, that is converted to the heat here. So therefore you can say kinetic energy is equals to the heat produced. Kinetic energy is equals to half mv square equals to heat equals to mc del T. Okay, so from this you can say m is cancelled out, so therefore you can say the rise in the temperature, the del T is equals to nothing but Cv square by 2. Nice. Sorry, V square by 2c. V square by 2c will be the answer, right? V square by 2c will be the answer. V square by 2c will be the answer. So V is given as 200 meter per second, that means 200 square by 2c, 2 into, this is 0.03. So this is 2 square means 40,000 is 20,000. 20,000 and this is 0.0 in calorie per gram. Okay, so first of all you have to calculate this calorie from, you have to you have to multiply, this is 4.2 in 10 to the power 3, right? 4.2 into 10 to the power 3, then and then you will get the answer. If you calculate all of this, like what you will get, 20,000 by 4.2, 0.03 into 4.2, that will become around 1.26, sorry, 0.126, that is equals to 126. If we divide this, so 20,000 divided by 126, it will become around 158 degrees Celsius. Okay, understood, right? Question number 43, sorry. Monoatomic gas is mixed with one monodiatomic gas, the mixture Cp by Cd. Okay, this is a simple thing. Cp by Cv, monoatomic gas, this is 5 by 2, Cp is equals to 3 by 2R, and Cv is equals to, this is Cv 5 by 2R, Cv is equal to diatomic 5 by 2R, and Cv is equals to 7 by 2R. So for the mixture, Cp will become 3 by 2R plus 5 by 2R, it is equals to 4R by 2, sorry, and Cv will become 5 by 2R plus, this is Cp, no, this is Cp and this is Cv, right? So Cp by Cv equals to 3RT by 2RT, that will become 3 by 2 means 1.5. That means the option number 3 is the correct option here. Cp has become 4. No, 4R. Cv has become 6R. So therefore the 2 by 3, not 3 by 2. Option number 2 will be the correct option, not 3. 2 by 3 will be the option. No, Cp equals to, sorry. It is like, no. Cp by Cv will be equals to Cp value Cp. For monoatomic gas is Cp is 5 by 2 and this is 3 by 2. Cv is not Cp, this is Cv. Cv equals to 6R and this is become 4R. So therefore you can say yes, 3 by 2 will be the answer. Question number 44. No. Question number 40. Given a cyclic process, the work done during the isobaric process. Okay, the work done should be like calculating the area under the curve. This is the curve. No, this is the curve. So this is the thing is that the pressure is given as like the final one is 3 into the power 2. This is 2 into the power 2. Okay, V1 is 1 and V2 is 3. So the area under the curve, we have to calculate this. The isobaric process, the formula is given as P into del V, that is V2 minus V1. P is 3 into 10 to the power 2 and the V2 is here is 3 and the V1 is equals to 1. So that means 3 minus 1 is equals to 2. 2 into 3 means around 6 into 10 ki power 2. So that means 6 into 10 to the power 2 means around 600 joule will be the answer. Okay, isobaric process, the pressure remains constant. So therefore, yeah, the pressure will be the this one only here, right? Question number 45. A cylindrical rod is used to conduct heat energy. If it conducts Q calorie per second, then what energy it will conduct if linear dimensions are halved? Okay, linear dimensions are halved. Okay, the linear dimension means like the only the this you can say the width and the length. We know this K by T, Q by T equals to K into A. The del T or the d theta or the del T equals to change in the temperature divided by length. Okay, so in this case the linear dimension means like the radius and the length. The radius is half, so therefore you can say Q is proportional to R square by L. This, so therefore you can say Q1 by Q2 equals to R1 by R2 whole square into L2 by L1. Okay, now you can see that this is Q1 is equals to Q, this is Q2 equals to R1 by R2 means R1 by 2, so that will become 4, 2 square means 4, L2 by L1, it is also equals to 2, no, R1 by R2 means R1 by R2, L2 will become half, so therefore it will become half, so therefore you can say this is 2 only, so therefore you can say Q2 will become Q by 2, so therefore it will become half times, so therefore option number 2 will be the correct option here. Okay, simple formula. The what did I told you, that the only the variable should be considered, all the total formula should need not be remembered, you don't need to write, sorry, like you have to just go through the formula only. A container of volume 200 centimeter cube contains 0.2 mole hydrogen and 0.2 mole argon gas. The pressure of the system is at temperature 200 Kelvin. This is a very simple. PV equals to nRT. Just put the formula, you will get the answer that N of the system will be equals to 0.2 plus 0.3 means 0.5. Okay, P is have to calculate, and this is 200 Kelvin. Okay, and volume is 200 centimeter cube, 10 to the power minus 6. You will get 2 into 10 to the power minus 5. Sorry, 4. Okay, just put the value in the equation. You will get that this is a very simple numerical. Very simple numerical. Okay, this is PV. PV equals to nRT, or this. The PV will be equals to nRT by V, right? So value, just put the value, N means equals to 0.5 and R is equals to 8.314 or 8.3, whatever you can say. 8.3, this is 200, and 200 divided by 200 to 10 to the power minus 6. So after calculating all the 200 cancel out, this is 4.15 10 to the power 6. So therefore you can say option number 4 will be the correct option here. Three vessels of equal capacity have gases that same temperature and pressure. That vessel contains helium, second one fluorine, and third one is the hexafluoride, sulfur hexafluoride, polyatomic, the correct statement. The root mean square. Okay, this is talking about, they are talking about the root mean square, RMS speed if temperature and pressure is equal, so therefore RMS will be depending on, the RMS speed will be depending on the V is proportional to 1 by root m. Okay, because T is M is like in this is constant. Okay, so the gas which has less M, okay, the gas which has less M will have more V. In this case, you can say helium has the molecular mass of fluorine has like 19, the sulfur hexafluoride has like around 71. Sorry, yeah. So therefore, you can say that the helium, the molecular mass of helium is lesser compared to all other two. So therefore, the VLM will be maximum for helium. Okay, because of relation, V is proportional to 1, V proportional. Okay, not yet easy. Root square speed of the gas molecule. This is 3 RT. Okay, pressure exerted by the gas. This is 1 by the N square. Okay, average of the molecule. The molecule is also 3 by 2 kb. Okay, 3 by 2 kbt. That is what we discussed. Total of 1 mole atom is 5 by 40. That means the freedom only 5. The degree 5. 25 minus 20 degrees Celsius kept into a calorimeter containing 20 grams of water at 25 degrees Celsius. Okay, when equilibrium is reached, the calorimeter will contain. Okay, the something this is. Gain of heat, loss of heat. So the formula is Q equals to MC delta T. According to the principle of calorimeter, the heat gained by the ice will be equals to 20 into 80, that is M into L, plus 20 into the 0.5 is the specific heat of ice, and the temperature change is minus 10 to 0 to minus 20, no, minus 25. Okay, so it will become around 1800 calorie. So it will become 25, no, it will become 25 only. 25 into 10 into 10, this will become 250, not this 250, this will become 1850 or 1800, more or less the answer will be equal, because this is the, you have to calculate the amount of heat that is, sorry, the amount of water or the amount of ice that is contained, because 1800, 1850 more or less it will give the same answer, but the precise calculation will be 1850. Heat lost by the water will be equals to 20 into 1 into 25 minus 0, because the water is at 0 degree Celsius when it is converted to the 25 degree water. Okay, so it will become 20 gram of water will become like this is 500, and the M into L portion will be there. 80 into 20 means the 2100. So from this you can say 1850 the heat gain, heat lost is greater than heat gain, so therefore the all the ice will melt down into water. So therefore you can say 40 gram of water will be there. Ice is melted and the previously 20 gram of water was there, so therefore the total ice will melt. So therefore we will get 40 gram of water there. Question number 50, last question. The lengths of L1 and L2 are made up of materials coefficient of linear expansion alpha 1 and alpha 2. If the difference on the lengths of the two rods independent of the temperature, then okay. So the thing is that this question is also asked in this kind of question is also asked in this year's in Neet. So the thing is that the two rods of length of thermal expansion coefficients